Happy Monday. So this week, it's a full week, so we did lose Friday. So this week I just want to focus on solving quadratic equations that factor. So what does that mean? Well, these are the steps, and I did post this in our Google Classroom. Let me go through them. You want to make sure your terms are in order. So you want to, first thing, rearrange the terms so they are in standard form. Now, if you forgot what standard form was from the fall, standard form takes the highest exponent written first and then down a step till there's no exponents. So standard form for us for the quadratic equation would be ax squared plus or minus is fine, bx plus or minus c equals 0. We want this to make sure equals 0. Sometimes step 1 is already ready to go. But every now and again, you have to move your terms over, so you'll see a couple examples here. Step 2 may or may not be necessary, but look to factor out the GCF, the greatest common factor. Step 3 may or may not be necessary. You're going to look for the difference of two perfect squares. That's where you use the square root method. So you factor difference two perfect squares. Step 4, if you see a trinomial, you want to factor using the AM method, which we'll review. And step 5 is new this week. Once you factor, you're going to take each of your binomials and set them equal to 0 and solve. Now don't forget, it's going to be really important to check, just to make sure. Great strategy for those of you who have to take standardized tests in your future where they're multiple choice and you forget how to factor, or you just can't find those terms to factor AM method. You could plug them in and use what's called the zero root property. So let's look at our first example. We're given here x squared minus 5x equals 0. Now, it is in standard form. I love it's equal to 0. I love the quadratic first, degree 2, degree 1. But what we have here is GCF. We need to factor out the greatest common factor, which is x. So we unmultiply the x. Leave me x, that's a monomial, with the binomial x minus 5. What do we do now? Because up to last week, we would stop here. Well, we're going to set everything equal to 0. Yes, even the monomial. X equals 0, and the binomial x minus 5 equals 0. What you do now is you're solving for the roots. These are roots. These are where it crosses the x-axis. You might remember we graphed parabolas earlier on. Obviously, can't review that with you now because we don't have the technology. But these are your roots where if you graph the parabola, we would cross the x-axis at 0 and 5. I don't mind how you present your answers. Some people don't like writing the brackets, so it looks like points, so they lose credit. So if you can write this, great. If not, just leave it. X equals 0, x equals 5. Now, what I wrote there in pink, it's not necessary for you to do. I know a lot of times people end up doing this mentally in their head. They add 5, but I'll show this here in case you're a little rusty. But those are your two answers. How can you check your work? If you go back to the beginning, if you plug in 0, 0 squared is 0, minus 5 times 0 is 0. Doesn't it check? Yes, it does. And you do the same thing if you plug in 5. 5 squared is 25. Minus 5 times 5 is 25, and sure enough, it does check. It equals 0. I usually don't ask you to show the check, but I know this week Mrs. Manchester will review the orders of operations. That'll get you ready for next year's math, and this is a great time to do the review of PEMDAS. But how PEMDAS comes into play here is you could take your answers and plug them in, especially like I said, when people have to take standardized tests or college placement tests and they forget some of the terms. If you take all your choices and plug them in and hopefully rule out by PEMDAS, you'll be able to get your answers. Okay, so that's a great strategy there. Example number 2, x squared minus 36 equals 0 is in standard form. This is a classic example of the difference of two perfect squares. So you take the square root of x squared, x and x, and the square root of 36 is 6. We need one sign of each because you notice how you go from degree 2 to degree 0. So degree 1's dropped. That's because you need opposite signs. Now what happens here, you would take each of the binomials, set them equal to 0, and solve. But there is another way you can write the answer. Maybe some of you are familiar with this. X equals plus or minus 6. So next week I'm going to show you the quadratic formula. It's probably the first time you've seen the plus or minus sign. But I can accept that as an answer like this or like that. So again, this here is an example where you use the square root method. The next example I want to do with you is example number 3 because we have a trinomial. So we're going to have to factor using the AM method number 4. We want to find numbers that multiply together give me positive 10. That reminds me that the signs have to be the same. But the two numbers I choose have to add up to equal negative 7. So you got it, negative 5, negative 2. So once I write down the binomial, I drop them down and set them each equal to 0. Now, some teachers do what they call the T-table method, just to keep everything organized. If you don't want to use it, no problem. I won't take any offense to that. But once you get this binomial, you set it equal to 0. Adding 5 to both sides gives you a root 5. Take the x minus 2, set that equal to 0. Adding 2 to both sides gives you your last answer, 2. So again, if you want to write them in brackets like this, you may, or you can just leave them as x equals 5, x equals 2. Example number 4. Now, this is very common as you take more advanced math classes. We have two things to keep in mind. First of all, example number 1 from the list. So let me turn this over here real quickly for you. Rearrange terms so they are in standard form. This first example for us is not in standard form. So what happens, we need to move the 9x over to the side to join the x squared. So 9 becomes now a negative 9x. No longer is it positive. The minus 20 on the right is on the wrong side also. So moving over to the opposite becomes plus 20. Now you're probably wondering, why did two terms have to move and x squared was a lonely term stayed? Whenever I solve these quadratic equations, whether it's x's or y's or w's, my leading term always is positive. If it's not positive, I need to change all my signs. So I always keep the x squared positive. It makes your life so much easier. Then once I tackle the standard form, then I realize, oh my gosh, it's another AM method. So I have to find numbers that multiply together, give me 20, but add up to negative 9. And sure enough, negative 4, negative 5. The last example for today has two scenarios to worry about. There's a 2 in front. We will tackle some more problems, as you can see here on this worksheet. There's more to come, where we need to use something called the quadratic formula. I'm going to save that for next week. But if there's a number on front, chances are right now it's your GCF. So factor out the 2. So unmultiplying both by 2 gives me x squared minus 49. That's the difference of two perfect squares. So using the square root method, I get x and 7. And remember, because we dropped from degree 2 to degree 0, these terms have to be opposites. Now, this is an interesting aspect also, because you're supposed to set everything equal to 0. This ends up being garbage. We reject it. Maybe you've heard of the word reject. We throw it out. That is not an answer. 2 and 0 never the same. Okay? Take the binomial x plus 7, say equals 0. When you subtract 7, you get one of your answers. X equals negative 7. Huh, that looks a little weird. Where's the negative sign? Where's my equal sign? Huh. And then the other one over here, when you add 7 to both sides, you do get 7. So again, you can use the brackets, or if you like the plus or minus, stacking the symbol on top, that's wonderful too. But again, this week we're going to be focusing on solving quadratic equations that do factor. And again, keep this list handy, because this refreshes our memory of the factoring that we did back in February and that we spent the past 2 weeks working on. If you have any questions, just shoot me a message, and the Google Classroom, email me. I hope you have a great week. Thanks.